And you are able to see screen?
Yes, sir, we are able to see.
So today I am going to start the Mapreduce. So first I will be starting with the theoretical part of the Mapreduce. So what is the Mapreduce framework? And next thing I will be going to start the practical demo. So I have like basically first I will be giving the complete theoretical concepts, like all the Mapreduce concepts, like what is the Mapreduce, what is the Mapreduce architecture, and how to write a Mapreduce program. And then some Mapreduce other concepts are there also, like there is a distributed cache, map side join, waiting side join, and partitioner is there, combiner is there. So these are mostly the theoretical concepts with practical hands-on on that. Okay, so it is up to you. Like if you feel comfortable, then you can do practice the Java example. I have the source code. So, but this is not that much important, because for interview point of view and what industry is using currently, that is high. High is Scoop, HBase and Spark. Okay, but for learning point of view, like we should have the idea about the Mapreduce, how Mapreduce framework works, and how architecture is behind the Mapreduce. Okay, because map and reduce two functions are there. I will explain it how Mapreduce works. Okay. So first I'm going to start like basic fundamental things of the Mapreduce, like why the Mapreduce came into the picture. Okay. So if I talk about like suppose I'll give a basic examples. Like I have a file system and I want to search some particular types of files. Okay. Suppose I say I want to search star.txt files. Okay, so I know in the file system, yeah, I'm speaking now. So everyone is getting the same problem, or only 1 or 2%? My voice is clear or not? Hello?
Yeah, it's good for me.
Yeah, my voice is fine, right?
Yeah.
Mike, are you still not able to hear me? Hello? Okay, I think we will be rejoining. Okay. Mike, are you able to hear me? Hello? Hello? Mike, are you able to hear me? Or you are still facing the same issue?
Yes, Mike, I can hear you.
Yeah, okay, fine. Yeah. Okay. So first I'm going to start with the traditional approach, right? Before the Mapreduce, like what is the traditional approach for searching the file in the file system? So if I take the example of the file system, the file is something like I say star.txt, extension type of file. So what will be the way of searching the file in the file system? So basically what we will be doing, we will be dividing the data, our data set, this is a large data set, and I will split the data, and each data set I will be doing separate searching. Okay, and wherever I'm getting my searching data, matches will be there. I will be concatenating. I will be collecting all the data from the different machines, and then it will be my final result. Okay, but this approach is like basically here is I'm manually dividing the data, right? Suppose I say I have a different drives are there, C drive. Yes, I'm recording. So C drive and D drive. Okay, so what I need to do, I have to divide the data manually. Like one, like now I have a whole data set. I say 500 GB data I have. Okay, and this is dividing into 250 in two drive, 250 and 250 in C and D drive. And then I'm doing manual searching. Then finally I'm doing the collection of these. Like I'm just counting the result. So here is the manual way I'm doing. First I'm dividing the data, then I'm collecting the data from the different drive. So that is a manual approach. So here is, if data size is very, very large, then we have a lot of issues, right? So we have to deal with the performance issue, right? And we cannot go for each and every machine, and we can divide the data and we can collect the data. So that will be really a big trouble, right? So another approach came, that is a Mapreduce approach. So in this Mapreduce approach is, basically I have a one large data set is there, okay? And I say like this is some text file is there, and this file I want to search the data, right? Suppose I'm doing word count program, okay? I'm taking one simple example. Suppose I have a file, and that file having the data like this. I say 3 lines of text is there. So if I say here the 4 lines of text, so here these words are repeating word. How is repeating, are is repeating, okay. So basically what I have to do, here is also splitting is done, but this splitting is done by the Mapreduce framework, okay. This is not done manually. So once the splitting is done, so different mapper machines, like map function will be applied on this data, and it will be returning the data as output data to the reducer. And reducer is doing the of the data from the different machines, and finally I will get the output in a single file, okay. So here basically I am providing one single input file and I am getting a single output file. So the main thing is here, the mapper and reducer function is all done by the Mapreduce framework, okay. But here is mapper control we don't have. Mapper control is in the Mapreduce framework and reducer control is in our hand. Because mapper control is in Mapreduce framework because it is automatically distribute the data into number of machines, right? So based on the input data and based on the data block size, right? So default block size is 64 MB or 128 MB. It will distribute the data into number of machines. And finally, when I want to collect the data, I will define how many reducer I want. So reducer is nothing but I want to say, like suppose I want to get the output in multiple output file, I can define the number of reducer. Otherwise, we can use single reducer. Okay, so single reducer the data from all the machines and finally will give the result. Okay. Okay, so simple, like I just show you here this is a diagram. So how the Mapreduce job is submitted. Okay, so name node we have a resource manager, okay, and node manager, and the container is nothing but our hardware resources. Okay, so these are data node 1, data node 2. So when the job is submitted by the client, like client is submitting a job to resource manager, and resource manager is allocating the task on the data node, okay, for the node manager, and node manager is having the application master. So application master is allocating the resources to the map task. Okay, once map task is done using the container. What is container? Container is hardware resources like memory, CPUs. So those things is required by the map task. So application master will allocate hardware resources to this map task, and once map task is completed, so all the node machines map task will be going to the reducer task. Okay, and reducer task is collecting the data from different node machines, different mapper machines. It will collect the data, and finally final output will be generated by the reduce task. Okay, that will be our final output. Okay. So here is these are the components, like basically what is the role of each component. So client is a component which is submitting a Mapreduce job. Resource manager is like a job tracker, like in Hadoop 1.x we have a job tracker. So similar role is there in the resource manager. So resource manager is basically allocating the task, like high level task it will allocate to the node manager. Okay, and node manager is working on the data node. So each data node having the one node manager. Okay, so whenever the task is received by the resource manager, so node manager is performing basically the task on the data node. Okay, so actual task is done by the node manager. Okay, so job history server it maintains the information about the all submitted Mapreduce job, right? So whenever job is failed or whenever job is completed or whenever job is they are killed, like whenever the job is killed. So these are the different states are stored in the job history server. Okay, and application master that is reside in the node manager, and it will be basically allocating the resources to the map task. So what are the resources? All hardware and memory resources will be allocated to the map task. And actual task is done by the node manager. Okay. Container created by the name node, because the name node is a master node of the okay, and it is allocating the certain amount of resources like memory, CPUs to the data node. Okay. So slave node is data node. Is it clear, this architecture? This is the architecture how the Mapreduce job is submitted. Okay, and the similar architecture is like now for the job submission is in the Scoop and Hive and HBase. Like whenever we are submitting any other type of component in Hadoop, so similar architecture is followed. Okay, because this is a high level architecture in terms of how the Hadoop services works together, right? Resource manager, node manager, name node and data node. Okay, so these are the two services are from the computing side and two services on the storage side, right? Resource manager and node manager is computing services, and the name node and data node is the storage services. So these are the steps are there for like final status update, and if any failure things happen, so it will recover the data, right? So these are the steps are there: task assignment, memory assignment, job initialization. So these all things are done by the Yarn Mapreduce application execution flow. This is again the same diagram, but just in the steps it is given, like how the steps is happening. Okay, so this is in the steps it is given. I'll share the PPT. These are the sequence flow diagram. So this is another way of presentation. This is a flow diagram, and this is a sequence diagram. So how this is a different components are there: client, resource manager, node manager, application master. So then request goes to the first resource manager, then name node, then application master. Application master is allocating the resources. So these all steps are in the form of sequence diagram. Okay. Okay. So next things like I want to show how the word count program the Hadoop Mapreduce framework will work. Okay. So this is a Mapreduce framework word count program. Like suppose I have 3 lines of text is there in my input file, and how I will get the output as word count. Okay. If you see here, beer is coming 2 times, car is coming 3 times, beer is coming 2 times, river is coming 2 times. So this is my final word count output, which is coming from this input file. So this process, like which is in middle you are seeing, this process is called Mapreduce framework process. Okay. So here I already told about whenever we are giving any input file, so we have a splitting process there. So splitting process is nothing but whatever lines of text we have, it will distribute the data into different lines of text. Okay, and each line is having like 2 parameters. One is key and one is value. So here key is offset number. So first line is starting at the 0 position, so the offset will be called 0th. But second line is starting from the 25th character, suppose. Because in this line, suppose 100 character is there, 10 character is there, 25 character is there. So this line offset will be 25, 100, depend on the first line having the number of characters. And third line is having different offset. So what is use of this offset? The offset is basically identifying where your line is going to start. Okay. So for this line, I say the K1 is 0 and V1 is this line of text. For this K1 is 25 and line of text I will say this line of text, that is called value. Okay. When this data is given to the mapper. Okay, so we have a Mapreduce program, and this Mapreduce program is distributed on all the data. So in Hadoop, we say, in Mapreduce, we say, data is distributed to the machines, or we are what we are doing in the Mapreduce is, because we know data size is very big. Data size is big. We can't distribute the data to the program. We can't distribute data to program. So better way is we write a program, that is a Mapreduce program, and this Mapreduce program is having three things. One is driver, mapper class, and reducer class. And this Mapreduce program, we are creating a jar, and this jar we are keeping it wherever data is available, specific to this file. Which file we are doing word count, there it will be distributed. This program, this jar will be distributed. Okay, so once a jar will be there on that data node, so basically the data is next thing is all the mapper machines, all the machines where the data is available, it will be doing the splitting. After splitting of the data, we will be doing mapping. So mapping is nothing but each word we are giving a one count. So suppose here is 3 words, so 3 words having the one count. So this logic is written in the mapper class. How the data will be distributed in mapper machine. So mapper machine's code will be, mapper code will be, it will read each line and split with space, and get all words and give each word one count. Okay, because each word is one time is there, we are giving one count to each word. Okay, so this is a mapper code. After that, next process is shuffling and sorting. So once shuffle and sort is basically, if same key is present on 2 different mapper machine, it will come to the one place. Okay, so beer is coming here and beer is coming here, so it will be shuffled to this machine. Car is here 2 times and car is here 1 time, so it is shuffled to here, and it is like aggregation of the data based on the key. So shuffling process is basically, here is again key and value, but key is nothing but key is on which word I want to do the count, and the value is number of key is repeated. So that is our list of values. So this shuffling phase, second phase is, first is mapper, second one is shuffle, and the third one is reduce phase. This is the complete part of the Mapreduce framework. Mapping, mapper part, shuffle part, and reduce part. Okay. So in shuffling, basically, it will be doing aggregation. Shuffling, it will be doing aggregation of similar key on same machine as list of values for same key. Okay, and it will sort the data. It will sort the data based on key. Okay. Now next thing is reducer phase. So reducer is getting list of values of same key and doing sum of values. Okay, and final count of all the values with key it will return. So finally it will return key comma sum of list of values, like 1, 2, so total 3 values are there, so total 3 as a count it will return, count of values. Okay, so this is finally reducer by done. So here if you see, Here BI is 1 comma 1. So it is again returning key comma value. And this key value is key is like the word which we are doing the count, and it's a total number of count. It is returning for each word, and that is our final output. So how many class we have to write in this code? We have to write one driver class. So we have to write one driver class. So driver class, we are creating a one job, job dot, we are setting set mapper class, that is a Java class we will set here. Which Java class we are using as a mapper class. Job dot, we are set reducer class. We will tell here which reducer class as a Java class we are using in our code. Okay, and two more classes, one mapper class and reducer class. So total 3 classes we are writing in our code. Okay. So this all code we are writing in Java. This all code we are writing in Java. So we are defining the Java classes, writing in Java code. Okay. So this is a Mapreduce paradigm. So basically how Mapreduce works. So Mapreduce is having two functions, one mapper and one reducer. Shuffling phase is done by the Mapreduce framework. So these 2 classes we have to write where the logic is written. So we have to write one logic for reducer. So this is simplest example, like we are doing word count, but we can do other things with the Mapreduce. We can do like the average, we can do some conversion of the format, like JSON format to CSV format we want to convert. So we will read the data, JSON data will read here, and finally we will convert to the reducer, or we can directly do in the mapper itself. So reducer generally use like when we have data distributed on multiple machines, and I want to get back all the data, and I want to, based on some key base, like I want to get the data back, and then I want to do some operation on that. So then I will use the reducer. Okay, one more example, like suppose one customer having multiple time order, like one customer data set is there, one order data set is there. Okay, so if I say, I mean, so far I am using only one data set. Okay, but sometimes I have a situation where the multiple data sets are there. How Mapreduce program will work? Okay, so I am saying customer data set is having customer ID, customer name, okay, customer name and customer order ID, okay, and order table I have order ID, order detail, and order cost. Okay, so here 2 data set I am reading in my mapper, but finally I have to do the sum of orders of same customer. So I have to use the reducer where I will read the one customer data and one order data, and I have to identify for the same customer if the order is more than one time. So I have to sum of the cost, order cost. So that is the example of reduced side join. So reduced side join is when joining thing we are doing the reducer side, and one join is map side join. So map side join is very simple join. Suppose I am reading the data in map file, reading data in map class, okay, and I am just showing as an output, okay. So suppose I say one example, like I have a employee data, okay, and I have an employee ID, name, and I have a department ID, okay, and one more data is there that I am using in the distributed cache, then department detail, okay, department. So department ID and department name. So here what I want to display, I just want to display employee ID, employee name and department name. So here I have to do the join in these 2. So this join I can do in the mapper side. So I don't need to go in the reducer side. Just simply I have to take the lookup, right? This department ID, what is the department name? And I can get the value of the department ID. I can concatenate in my employee record. So this kind of scenario is called map side join. join. So here we are joining, right? We are joining the two data set in the mapper side only. Mapper side only. So no reducer is required. But suppose if I want to do calculation like on the reducer side, like this order one, so here we need a reduce side join. So reduce side join is like if one customer having multiple order and I want to do the sum of all the order cost of that customer, that I can do only in reducer. Okay, so basically I have to identify the same customer and then I will aggregate all the order and then I will get the total cost of that customer order. Okay, so that is called reduced side join. Okay, so there are many use cases are there. Okay, so we can use it in Mapreduce. Any questions so far? Is clear? I am jumping to the another PPT. Okay, so where I am just going through some other concept. This is a one fundamental concept like how Mapreduce work. Okay, so how this word count program, how it works internally in Mapreduce framework. So we have a simple straightforward the processing is there, and each step is divided into the some part, and one step the input is given, and whatever output is generated, it is given as an input to the next step. So that way the process goes, and finally we get the output in an output file. Okay. Okay. So these are all concepts. So next concept is there. Okay. So what is input split is there. Okay. And one is a block. So two concepts is there. One is a block and one is an input split. So when I say the data is divided as a physically, that is called block. And when the data is divided logically, that is called input split. So when I talk here, like when I'm just processing the data in the word count, so in word count program, when I'm giving the data to after splitting the data and giving to the mapper machine, that is called logical division. Okay, because data is while processing the data, we are using input split, but physically the data is present in the form of block. Okay, so when we are writing any program, so input split comes in picture, and that is basically a logical division, and it is coming from this SDFS block. So suppose I say my block size is 64 MB, so input split size will be coming from the block. So one single line it is giving a one block. Like this it will distribute the data. Suppose I have a 10 lines and one line is for one block, so it will be creating a 10 input split. Okay, so one block is one input split. Like this it will be distributing the data, and that one input split will be given to the mapper. And finally mapper will be splitting the line, and then it will be calculating all words, and then each word will be given the one count. Okay, so here is the division. So suppose I have the block is there, and block is divided into the input split. Okay. So input data is distributed to nodes. Each map task works on the split of the data. Mapper output intermediate data. So mapper's output will be going to shuffle process, and shuffle process output will be given to the reducer process. Okay, this is the flow. This is the final output. You will be able to see that is the same process flow which we have seen in the word count, but here it is just telling about what are the logical components are there. Mapper component is there. This is shuffle and sort is there. And this is finally reduce component, and this is final output. Sometimes we can get the multiple output, multiple reducers. Okay, so that is coming through the partitioner. So suppose I tell one example. Suppose I have a one input data set, and this input data set is having words. Okay, and I am getting final output in single output file. single output file. And this output file is having all the words. Like I say, word is starting with the A letter word is there. Okay. B letter word is there. Okay. So how can I identify how many words are there which started with, from the A letter? So I have to do it manually, right? I have to find it in the file manually. But suppose if I want to write a logic of partitioner, which can distribute data into partitions like multiple output files. That is called reducer file. So what I need to do, one Java partitioner class I have to write. Similar way, like I have written already mapper and reducer. So I have to write one class is my partitioner extends partitioner. Okay. So I have to extend partition. There is a one method is there, get partition. So get partition methods I have to override get partition. It is passing the number of reducer. I have to specify how many reducer I want. So suppose I want to distribute the data into separate letter file. So I need 26 reducers. So I will be passing 26 as a number. Okay. So I will be passing 26 in the number of reducer in this, and then I will be writing the logic in this method. I will be writing a logic of like how I will distribute the data. So basically, I will be using the modulo operator. So I will be passing the key also here. Okay. So based on the key, I will use the modulo operator like key %1. Okay. Key %2. Like this, I will distribute the data into 26 output files. Okay. So I will be specifying the logic like how this condition will work. Like if I say if my key is start with A letter, I write like this for A. If my key is start with A letter, then I will be distributing the key as a key %1. Okay. Same like else if condition I will write. If key start with letter B. So this is the logic we have to write. And once this logic is performed, so output files will be 26 created. Okay, because before going to the reducer, it will identify if this key will be going to the which reducer. Okay, so it will identify the file and it will create a separate file for that key basically. Okay, and if the key is coming for the like A starting, key will be going into the one file. Like this will be the logic will be written. Okay, so there are many more examples of partitioner is there. So there are two concepts in the Mapreduce. One is a partitioner. So partitioner determines which reducer is responsible for particular key. Okay, so partitioner is used for the like human readability of the data. Right. Suppose I am not able to get the information one single output file. So in that scenario, I will go for partitioner. Okay. But combiner is another concept. So combiner is kind of mini reducer. Okay. So what is the role of combiner? So sometimes when you are writing any Mapreduce program, so what issues comes in the Mapreduce program, I'll tell you. Suppose I have one map machine is there. So in this map machine, okay, I'm saying one key is one time. Okay, it is fine because it will be doing key comma 1. Right? It is giving a one count to that key. But suppose that one key is 100 times, 1000 times or 1 million times. So how many times it will be doing? It will be doing separate 1 million times. Like key, comma 1, key, comma 1. Same key it will be doing 1 million times. So when the data will be going to the network, right? After this mapper phase, the next phase is shuffle and sort, right? So when shuffle and sort phase, the data will be traveling on network. So this 1 million times data will be traveling. The key is same, right? Instead of sending repeated key on instead of sending repeated key in the network, instead of sending repeated key on network, what we can do, we can aggregate keys itself in mapper machine. Okay, how we can do it? We can apply same logic of reducer. So if I write one Java class I write my combiner, and I can say it is having the same code of my combiner class, which has same code of reducer class, or even where I'm setting in the job, right, in driver class job dot set combiner class. So we have to give this parameter set combiner class. So either I should create a new class which has the reducer class code, or I can directly say reducer class here, reducer class name, reducer class dot class. I can provide like this. So it will understand the same reducer code we have to apply as a combiner. If I don't write this thing, it will not bring in the picture. The combiner will not bring in picture. So when I want to use partitioner also, I have to set a job dot set partitioner class. So when I'm writing like this and I'm giving a partitioner class name, partitioner dot class, so partitioner class logic will come into the flow. Otherwise, partitioner class, combiner class, this logic will not come in the flow, and it will behave like a same Mapreduce program. So combiner we are using for performance, because the performance will be improved, right? Rather than sending the 1 million key 1 million times, so I will be doing key comma 1 comma 1 comma 1 comma 1 million time I write one map, and that map I will send on network. So it will reduce the separate 1 count. I don't need to send. I will send the key comma 1 million times, one single map I can send. So that will reduce my network overhead. Okay, and it will improve the performance. Okay, because finally when the reducer will read it, what it will do? It will do the sum. Final count it will do, and it will give the word count. Okay, so that is the use of combiner. So combiner is called the mini reducer because it is acting as like a reducer. Okay, but it is not the complete reducer, but it is acting like a reducer. So whatever reducer can do, same thing we can write in the combiner class, and combiner will do the same functionality of reducer at the mapper side. Okay, so that is called combiner. Okay, so there are the two concepts. One is partitioner, one is combiner. So I'm just going to tell here just concept only. Later I will be just showing you the program, like how we can write a Mapreduce program. So how can we enable combiner? How can we enable partitioner? Okay. So basic concept is need to be understood first, and then after we can start the implementation of this concept like combiner, partitioner. Okay. So here if you look at, so they have shown the combiner. If you see, B is repeating 2 times. So what the combiner does, it is aggregating the data, and B comma 2 it is returning. Okay. So it is doing that whatever count it does after the shuffling, reducer does the same thing combiner has done here. But here, reducer is going from different mapper machine data. Suppose B comma 2 is here and B comma 2 is here. This part cannot combiner does. Combiner can do only in the same machine. Okay, but different mapper machine output data can be combined by the only reducer. This reducer which is coming after the shuffling. Okay, so this is the different blocks of data is coming to the mapper. Mapper is giving the one count to each word. Combiner is doing the summation, aggregation of the each key which is repeated in the same mapper machine, and the shuffling is aggregating, like it is just shuffling the similar keys data to the same, and then finally reducer is doing the count, right? It is doing the count for each word. For each key, how many values are there, it is doing that count. Okay. total count. If clear this one, this diagram. This is a combiner. Okay, combiner works at mapper level. Okay, because it is doing mapper side. Combiner can be considered as semi-reducer. Okay, and partitioner is we are generating the multiple output files, right? So this is one mapper output is there, one mapper output is there, one mapper output, and this mapper output is given to the partitioner class, and partitioner class having the logic to which reducer your output will go. So if your whatever the map key is coming, if it is matching with that partition key, so it will send to the output to that particular reducer. Okay, so that logic is written in the partitioner class. So combiner and partitioner, these are the two concepts. So I'm just going through a little bit code, but tomorrow I will show the complete program, right? Okay, so here you can see when I'm writing a Mapreduce code, right? Mapreduce code, so we have to write one mapper class and one reducer class. So you can see here, this is the one mapper class is written, map, and it is extending from the mapper. This is the abstract class. So we are returning it. Okay. So here simply, this is a different example. Like here it is doing some different, but if we have to do word count, so we have to split with the space. Okay. Okay, I'll check the test example. This is something related to encryption, decryption part is doing. So it is handling the encryption, decryption to Mapreduce. So when we are writing a mapper class, so mapper class, this is a word count mapper, just any name we can give in the class, okay? And we are extending from the Mapreduce mapper class. So here, basically when we are getting a two things, actually here two part is the input and two part is the output, okay? If you see here long writable, this is your offset, and this text is nothing but text of line. Okay, so here in the Mapreduce we are having a text is it is representing to the string. So whatever we say in Java string, that is text here, text. Okay, and whatever classes we are using, int, long, so those are called here the wrapper classes, int writable, long writable, double writable. So like this, it is a Hadoop implement. So these classes are serializable classes. Like simple int and long is not serializable. So what is the use of serializable classes? The use of these serializable classes is like we can transfer the data over the network, right? In the Mapreduce framework, we are traveling, the data is traveling over the network. So data state should remain same. So whatever value of the data is there, right? Whatever the key having the data, so that should remain same. It should not change. That purpose we are making it serializable classes. We are using the serializable classes, int writable, long writable. Okay, so when I want to use in the Java, this serializable object, I have to convert into the toString, or I have to do that. Okay, so first what I'm doing here, I'm getting, this is the two input part and this is output part. So my input is coming as a offset and text of line. And what is my output of the mapper? Key comma value. So key is the text and int writable is a count. 111 count, right? For each word we are giving one count. So what I'm doing here, when I'm reading this offset and comma text, so here whatever text is coming, I'm converting into the string data. So this is the value, right? So my function, if you see here, this is a function here, map function. So we have to override map function. In this map function, you see long writable key and text is a value. So each line of text we are passing as a text as a value. So when I'm getting the value here, I'm converting into the string because I have to do some Java manipulation. So this is a serializable type. This text I am converting into the toString. I'm converting into the string. Once I get this line, I'm tokenizing this line. Actually, I will be splitting the line into the multiple words, and then I'm iterating the each word, and then I'm setting it word comma 1. This is nothing but a constant. This is a constant one number, right? So each word I am setting as a 1. So are you able to see here one reporter object is there? Reporter is like collector, like common object where I can read and write the data, right? So when mapper is writing the data, it is writing one common object that is called collector, output collector. So this output collector object, we are writing the data, and the same output collector, shuffle and sort, is reading the data. Okay. So this process is going on. This is a common object where we can read and write the data. So here mapper is writing the data in output.collect as well, each word is a key and 1 is a count. Okay. And once it is written into the output collector, so next process is reduce. But before that, when this reducer program called, before that shuffle and sort is already done, right? Because shuffle and sort we are not doing. Shuffle and sort is done by the Mapreduce framework. Okay. So when reducer class is called, so reducer class is also taking the 4 parameter here. 2 are input and 2 are output. So text comma int writable, we are returning from the mapper is text comma int writable, right? Last 2 parameter. So these last 2 parameter will become input here, comma int writable. Again, output parameter is again same, because final output is generated by the reducer, that is text as a key, and int writable is final output. Okay. So what I am doing here, I am overriding here reduce function, and this reduce function is taking the text as a key and iterator of int writable values. So suppose we are returning the multiple values, right, for the same key, 1 comma 1 comma 1 comma 1 comma 100 times. If word is repeated 100 times. So 1 comma 100 times values are coming. Those are list of values. Those are list of values. So for that, what we have to do, we have to iterate a loop. So I am looping the here while values dot has next this list of values. If values is there, I will be doing a sum. So initial sum is 0. Then I will be adding the values into my sum 0, and final output will be my total number of count. Okay. So again this value is serializable, right? Text. This value is number int writable type. So what I am doing here, dot get. So values dot next dot get function, I will get actual value of int writable, this value. Okay. So suppose 100 1 comma 1 comma 1 comma 1 is there. So final sum will come 100. And finally, I am writing here output dot collect. I am writing it keys, for which key it is doing the sum. So suppose key is hello, and the key is coming 100 times. So what will be the sum? 100. So 100 key comma 100 will be written. Hello comma 100 will return. So that will be my output. But one more driver class is there. This is a driver class. So driver class only just we have to do this configuration. So what is the configuration? Just I am creating a job object. This is a job configuration object I am creating. Okay, and this job configuration object I am setting it. What is my combiner, mapper, reducer. Okay, and 2 more things we have to provide. What is the output format? What is the input format? So that type of format also we provide. Okay, so output format type, like we are specifying here, my key will be a text format. I set output format like my value is a text. So output or input format type or output key type. Input key type or output key type, or output value type or output key type. So 4 things I have to define. My output key is text type, or output value type is int writable. That is this one, text comma int writable. And whatever my input type, both are input type text, set import type format, and this is for key. I think here it will come int writable, okay, long writable, which is my this format, this data. Long writable, this is offset. And import type, that is text. Okay, so that I have to define here, then I will call the run job. So run job will trigger our mapper and reducer class, and finally reducer is giving the output. Okay, so it is little bit complex, right, to understand initially, but when you run the code and then you will see the flow, right, how mapper, reducer and shuffle and sort works, so it will be easy to understand the flow. Okay. Okay, I will show complete this Java code, how to run and how to check the output. How can we verify the output like this, like each word, like what is the count? Okay, we can see in the output file. So some output file is generated, and this output file we can see the result, and we can check each word is how many, like what is the count for each word. Okay. Any question in this Mapreduce framework? Anything in this program? I'll just repeat it again tomorrow when I will show in the Eclipse. Okay, so I will show this program and again I will run it and I will create a jar and then I will submit on the cluster. And even we can run the program in Eclipse. So two ways we can do. Either we can create a program in Eclipse and run in Eclipse itself. And the second way is like we can create a jar and we can submit on the Hadoop jar command, we can submit in the cluster. Okay, so two ways we can run. Okay, so first way is like Eclipse or IntelliJ, that is for testing purpose. Like I can see the output. But when I want to finally submit on the cluster, so I have to submit on the cluster. Like I want to, like production or UAT cluster, I want to submit. So then I have to submit a job in the cluster. But when I do the development and testing, so I can do in Eclipse or IntelliJ. Okay. So any question, anyone? I'll explain this completely tomorrow and some other concept, map type join and reduce type join and partitioner, combiner, all those concepts, programs also I will show so that you will get a clear idea what are the concepts are there in the Mapreduce. Okay, I'll share the slides also, so you can go through one slides. Yeah. Yeah, I have already recorded, so I will share the recording in the YouTube channel link. Okay. Yeah. Okay, thanks a lot for attending the session. Thank you. Yeah. See you next tomorrow. Yeah, bye.
Yeah, thanks.